Hi, everybody. Thanks to be here. Kalispera. Ophilimi. My friends, Ophilimi. Does it work? No? No. Ophilosmu is my friend. Singular. Ophilimi is plural? No? Ifilimuamu is not conjugated. Yeah, of course. That would be too easy. Thanks to be here for this talk about OpenTelemetry. I'm Nicolas Frankel. For a long time, I was a consultant working in projects, having managers, having schedules, having deadline. That was super stressful. Now I'm a developer advocate, so I travel the world. I get paid to talk in front of people and drink beer. Right? That's what developer advocates do, right? Now, I had this interesting discussion yesterday, like, yeah. That's what you imagine, so let's play the role. So you might notice that I'm a bit old, or I would say experienced, which is much better. And when I was younger, we didn't talk about observability, we talked about monitoring. Monitoring at the time, that was a bunch of people, like sitting in front of screens. In general, there was a big dashboard, a screen. Still the case for you? Looking at a big screen wall, and there were dashboards, and when something happened, well, they could actually do something. That was the basics of alerting, like a bunch of people looking at screens. It worked for a while, but our system got more complicated, more complex, more distributed. I try to explicitly avoid the M word, like the microservices word, because a lot of people think they are doing microservices. No, you are just doing like distributed monolith. Yeah, you got none of the benefits and all of the trouble, but you can put microservices on your resume, which is super great at the moment. Everybody wants microservices. Anyway, there is no denying that our systems are increasingly becoming more distributed. Whether we like it or not, we distribute our system. I mean, even an app and a database is a distributed system, right? You have two components that are not hosted, generally not hosted on the same machine. So we had to do something better, and this better stuff is observability. Since I'm super lazy and I've been told that you should never read out your slides, then I've just copy-pasted the definition of observability from Wikipedia. Actually, it's missing a bit, because observability nowadays is defined on 3 pillars: metrics, logging, and tracing. And though this talk is mainly about tracing, I want to talk a bit about metrics and logging, especially about logging, because not many people get it right. So the good thing is, in general, all organizations do metrics. Who is not doing metrics? Yeah. Good, great. Everybody does metrics. That's what I did when I was younger, so you should do it as well. What I just could advise you is just not to just like track CPU and disk usage and memory, because this is completely useless to the business. Just like get metrics that have a bit more business value. Imagine you are an e-commerce shop. Perhaps it's not the number of orders per second, just the number of like successful HTTP requests versus the number of unsuccessful HTTP requests can give you a good hint and is actually helpful. So I believe that just the only advice I can give you. Logging is a bit more complicated. The thing is, when I was a young engineer, I thought, wow, I'm very smart. I'm smarter than everybody, like I'm an engineer, right? So instead of asking developers to log stuff, I would just create a Java agent. I mean, who here is a Java developer or a JVM developer? Okay, oh, half the room, that's interesting. So Java agent means you don't ask the developers to do anything, you just change the behavior of the bytecode at runtime. So the developers are completely oblivious. So I created a Java agent to log the input parameters of a method and to log the return value. And that was very smart, because now the developers, they didn't need to do anything. I had a nice like log. And then I forgot about the password. So, yes, it was very fast, it was very cool, it was very smart, but I forgot a lot of stuff. So back to basics, you need to explicitly log stuff that you want to log. There is no automated way or smart automated way to do that. And you should put as much attention to the logs when you are doing reviews as to regular code. Hey, look, here, there is a performance issue. Yeah, but here you are not logging something that you should probably log because there will be an issue. So that requires, I'm afraid, some effort. The second thing is the logging format. We actually are no more logging to the machine and reading the log when there is an issue. First, there is a high chance we don't know the machine. Second, there is even a higher chance that the machine is long gone because it was a container. So there is no way you can actually connect to the machine and reading the log like you did in the past. Probably you have a log aggregation system somewhere. And the thing is, when you are aggregating logs, you are probably like structuring the logs. And if you write the log in a human readable format, you need to grok a pattern so that it's transformed into JSON and then it's ingested. And if you are doing that, you probably have a component somewhere in your system that does it, which makes it more fragile, more complex. Why don't you just output the log in JSON directly? Who is outputting JSON directly? Who will be doing it tomorrow? Okay, I have convinced some of you at least. Great. Afterwards, we need to remember that things change all the time. Previously, when I started my Java career, I was forbidden to log on the console. Forbidden. It must be a file. Okay, I will just apply what you tell me because you are more experienced. And nowadays, you are probably using containers. And if you are writing to files, it's a mess. Where do you output your logs? Console. So that changes all the time. Now it's console. Perhaps in a couple of years, we will be back to files again. Couple more questions to ask yourself is, how do you get the log? Do you pull the log from the system? Do you push the log to the log aggregating system? There are pros and cons. How do you pass the log? I already told about it. You shouldn't pass the log. It should be ingested naturally. Where do you store the log? And then pay for it. Hello, Datadog. And then your system probably needs to be able to search the log, because if you have lots of log, you cannot search them. It's useless, and display the log. So here are a couple of systems. I am more familiar with the Elastic Stack myself, but I mean, I have no preference. I told you I'm a developer, I'm not a DevOps guy. Now come the traces. Metrics, everybody does them. Logs, most companies do them more or less correctly. Traces, not many people do traces. Who here is already doing traces? Wow, that's a lot. Great. And I don't like this definition, actually. So I came up with my own, which I probably read it somewhere, I don't know, but for me, tracing is the way to track business requests from the entry point into your information system and back to its originator. That's very, very important. And if you already do tracing, you probably either are using or have heard about any one of those systems. Zipkin, Jaeger, or OpenTracing. Those were the pioneers. Those were companies that understood that it was very, very important to track your request across several components. The problem is every one of those frameworks or organization or components did it in their own way. And so the problem is that when you were choosing, assembling your information system, you needed to check which one you would be using and to have a tool that was compatible with it, or that had a library, because, I mean, it would be useless to do that yourself. That's the problem. I always see the photographers. Yeah, you need to be smaller and, yeah, I'm sorry. So when there are many competing components, what do we create? A standard. You have 14 competing standards, then you unify them, and now you have 15 competing standards. So in order to avoid that crap, we need a good, like, trustable organization. And W3C is one of them. And actually, they came up with a spec, like the HTTP request trace spec. Who knows about the spec? Okay, great. So I don't ask who read it. And it's like 20, 25 pages, very easily readable, but just for the sake of it, I've just, like, I will summarize them. Basically, it defines two abstractions. It defines the idea of a trace, which is a business request that flows through several components, and the idea of a span, something that happens inside in one of those components. There can be a single span inside a component, there can be multiple spans, like internal spans inside a component. And they are bound, the spans, they are bound in the parent-child relationship. So this is how it looks. Here I have my trace, and here I have three components, X, Y, and Z, and my trace goes through all components. And then X is the first component, and then it, like, calls to other components, and each of those components, they have their own spans. And so Y and Z, they are spans, and their parent is X. X has no parent, it's the first span. And they all belong to the same trace. So that's not rocket science, right? It's very simple. Every idiot can understand it. I mean, I did, so. This is how it works. But the thing is, now all your code would need to create such a trace, right? You would need a trace ID, you would need a span ID, you would need to implement how you create the next span ID. So in order to make things easier, there is OpenTelemetry. And OpenTelemetry is not only about the trace context, but it implements the trace context. OpenTelemetry does logging, does metrics, provides set of tools, SDKs, everything. But it implements the trace context. And it's a merge of OpenTracing and OpenCensus, which is great because it means that it's one of the few successful open source mergers that I've seen. It's a CNCF project nowadays, and I believe that it's the next big thing. I mean, if you came to the room, probably you are convinced about it as well. You hear a lot of things about telemetry, about OpenTelemetry, but more importantly, nearly every provider, every framework implements somehow OpenTelemetry. It's just a big black hole that is pulling everything around. How does it work? Well, as I told you, it provides SDK and libraries and frameworks, but more importantly, it defines the OpenTelemetry protocol and the OpenTelemetry format. And that's how you send OpenTelemetry data to an OpenTelemetry collector. OpenTelemetry provides an OpenTelemetry collector, but its idea is to receive, collect data, and then dispatch data further. So basically, what happens after the OpenTelemetry collector, it's not relevant. They don't care. The OpenTelemetry collector provided by OpenTelemetry is just a convenience. They don't force you to use it. And basically, what did Jaeger and Zipkin do? They provided an OpenTelemetry port to their existing collector. So you can keep your infrastructure, just open the port, change the way you send the data, and you can reuse everything. And at this point, you can move between Jaeger and Zipkin and the OpenTelemetry collector and the next cool database that will be very nice in terms of storage cost. So the idea is I'm talking to developers. Who here is a developer? Who is not a developer? Oh, who is a DevOps? Who is an Ops? Who knows the difference? Okay, for the ops-minded people, this is what you will tell your developers. For the developers, this is for you. The first thing is it depends on the stack you are working on. If the stack has a runtime, you can have auto-instrumentation, just like I did with my stupid logger before, but this is better. I mean, it's for tracing, it's not for logging. And it's very easy. Your developers don't need to know anything about OpenTelemetry. You don't even need to tell them about OpenTelemetry. So if you are an ops working on Java, for example, at runtime, you just add the agents and you're done, which is great, right? If your stack doesn't have any runtime, then I'm sorry, you need to care about it yourself. Stacks that have runtime, the JVM, Python, Node.js, stacks that don't have runtime, everything that compiles to machine code like Rust, for example, C++. If you start with runtime instrumentation and you are happy, and probably you will be happy, then you can go to your manager and tell them, hey, look, that's really good. I managed to debug that stuff that cost close to zero, we did it under the cover with no budget. Now we would like to be more precise. Then you can go to the second level. You can start with auto-instrumentation, and then afterwards do manual instrumentation. But it will be more expensive, so probably you will require a budget. If you have a runtime, I probably recommend you to use the auto-instrumentation, because it can be done in a couple of seconds. I kid you not. It will have close to zero incidents on your performance. You need just to set up a shadow database somewhere, a shadow collector, and you will get results. And I've talked a lot, and now I want to show you some example. So I've worked in e-commerce before, so I like to use this example. So here I have a request. So this is like the home page, or the pseudo homepage for an e-commerce shop. So I will need to display products, and I will need to display their price, and I will need to check if they are available, because it doesn't make any sense to display a product if they are not available in the inventory. So this is how it looks. I have a request for products, and then I have the API gateway, or the reverse proxy, but okay. Or the reverse proxy that forwards it and does its magic. Then here, I will ask for all the products to the catalog. The catalog is a JVM-based Spring Boot application coded in Kotlin, because I love Kotlin. Who here loves Kotlin? Not enough people. I need to come more. Then it asks for the prices to a Flask app coded in Python. Then it asks for the number of items in an inventory coded in Rust. Any Rust developer here? Nah, don't be shy. I probably won't show you the code because I'm not a very good Rust developer, so my code is probably shitty. Python anyway? Okay, so I probably will have time for two. I will skip the Rust stuff. And then, because I've been asked a lot, I have like for asynchronous communication, how does it work? I've added an MQTT broker in between, and I have a Node.js app that will just subscribe to the analytics of the requests. then I won't show you the code at all because I really suck at JavaScript. Just managed to get it working. The entry point is the most important one because it's the one that will generate the trace ID. Okay, that's easy. It's the one that will generate the span ID. Yeah, that's also easy. But it's important for the third reason. So here I'm using Apache API 6. In case you didn't notice, I work on the Apache API 6 project. I have just one slide about it. Who knows about Apache API 6? One person. Great, I'm in the right room. So who knows about Nginx? Yeah. So Nginx is very good, very stable, very mature reverse proxy. It just has one little flaw, especially the open source version. If you need to change the configuration, you need to switch it off and on again. It's not great when this component sits at the entry point of your information system. So we need a way to reload the configuration dynamically. For that, we have OpenResty, which is a Lua JIT. It allows you to change the configuration with Lua code. The problem is the configuration of OpenResty is nearly a duplicate of configuration of Nginx. And so basically, with time, maintenance will be harder and harder. For that, we have Apache API 6. We have abstractions, routes, services, and everything is a plugin. And that's all for Apache API 6. Just, I mentioned there is something important. On the entry point, it's the sampler. Because if you have 1 million requests, you probably don't want to have 1 million traces. So you need to reduce the number of traces. You need a sampler. This is the most important stuff. And probably it will be dynamic over the lifetime. When you set up OpenTelemetry, probably you will have a high sample, perhaps let's say 5%, depending on your number of requests that you receive. And then when it's stabilized again, then you can decrease it. Then perhaps you deploy a new component, you will increase the sampling again, and then go down and this and this. Okay. You still hear me? Okay. Now, I have created a Docker Compose file, so I will start it, and I will continue describing it while it starts. Not start, up. I will down it everything, because yesterday, yeah, I knew it. Yesterday, I updated it with the latest components, so this is a demo effect.
I think we are not seeing it.
Thanks a lot. That's what I expect from a conference in Greece. Feedback. We are not in the Nordics. You are from the Nordics?
No, I just do a little NDC.
Yeah, and you know how it works, right? You know the joke? How do you recognize an outgoing Finn? You are talking to a Finn, how do you recognize them? Sorry?
You're talking to them.
No. They look at your feet, not at their feet. Any Finn here? In general, they are big and strong, so yeah, I should have asked before, but you know. So I'm using Jaeger for no reason other than it's very easy to set up. I've got the Docker image. I just enable the OpenTelemetry collector with just like one environment variable. I'm using Apache API 6, obviously. It's not funny. I'm using the catalog. I will show you the code afterwards. I'm using the pricing, the inventory, and I'm using a Postgres database with like single database, different schemas, and everything is nice. I showed you the config on the slide, but here I can show you the real config. It's the same. So here I'm configuring Jaeger, and here I'm saying that I have a global rule. So I told you that API 6 is configured for plugins. Normally, you can see here I have a plugin per route, but here I want to like englobe all the routes that will be created in the future, in the present, and the past. So I say I have the plugin on telemetry. and it will apply everywhere. And here I say the sampler is always on, because obviously I don't want to send 1 million requests to get one trace, right? So I will have one request, one trace. Java developers, yes? Yes, half the room were Java developers. So here is my POM, and you can see that there is nothing OpenTelemetry related. Nothing. So you trust me? Great. You shouldn't, I'm French. Everything is on GitHub, so in case you don't trust me and you would be right, you can check by yourself. So here I do the product stuff. And I can show you as well the Python stuff, which is, I don't see it, no, not here, it's here, the pricing. Here I'm using Poetry. Here as well, there is nothing that is OpenTelemetry related. And still, I do a request. I go to the Jaeger UI, and if I do it rightly, I can find the trace. So here, this is how it looks. Great. So this is my trace. This is one trace, right? And you can see the spans in each component. Even if you are not DevOps oriented, even if you are an architect, you don't care, you can see still some interesting results. So the first thing, you see API 6 is calling the catalog. Well, that's what I would expect from my diagram. The catalog itself is calling the inventory, that again, what I was expecting. Here we can see that the catalog is calling the inventory directly and calling the pricing through the API gateway, which is not wrong in itself. The question is, as an architect, I would just ask myself, hey, why are you calling the inventory directly? Probably for performance reasons. And why, on the second time, you are calling the component through the gateway, probably for authentication and security reasons. So you can ask yourself why, which is the good way to start a conversation. So again, you're not interested in OpenTelemetry, in DevOps, whatever, you are an architect, you get some actionable results. Something that I'm not good at is concurrent programming, right? And normally, my catalog should actually call the inventory and the pricing at the same time. They should do it in parallel. Good thing, I managed to do it correctly. Again, you are a developer, you are not like the expert of concurrent programming. Fortunately, I use coroutines, so that makes the stuff, but still, sometimes you don't know how to use coroutines correctly. Here, it seems I got them right, so basically the calls are in parallel, I don't lose any time. What you don't know, but that I know I have 3 products, and every time for each product, I'm calling the inventory and the pricing. So I have to do, like for the demo, I did it on purpose, obviously, because I wanted to have a nice trace, but I'm not batching. So if I have 20 products, not great idea. So that's already something you can see. Every span has additional data. So here we can see the HTTP status code, we can see the user agents, we can see a lot of stuff. And depending on the component that you are using, you can add additional data. So for example, on the API 6 side, we can see that I will trace the X hotel key, so I didn't pass any, but now if I curl again, I don't have that much time, so I need to speed up a bit. I will say, hello, Devoxx Greece. What did I miss? Thanks. Thanks a lot. And now we get back to here. We find the trace again. The new trace is much faster than the second. That's obvious. We still have the same number of sand, which is good. And and we can check, and here we can see that I have this X hotel key, hello Devoxx Greece. So you can track additional stuff. Some people are saying that these traces will replace logging at some time because you can attach additional data. I don't know. I'm just a developer. So we already have something, but how did it manage to do that without even adding any OpenTelemetry to our developers? Right? How? How? Java agents, thanks a lot. And because I'm using containers, I can show you the Docker file. And this is like very, very simple. So this is a multi-stage Docker file. The first stage is building with a JDK. I'm compiling, I'm creating the jar. The second, I just need to run. That will be my final image. I take the jar that I've created in the first step, and I get from the internet the latest version of the OpenTelemetry Java agent. And when I run the stuff, I add the Java agent. Yes?
So is even the Python bit running on top of a Java layer that's got this?
No.
Because you didn't have the OpenTelemetry package in the Python.
Yes. And because Python has also a runtime, and I can do the exact same trick, it's just not a Java agent. So I can show it to you since you are interested.
I thought it was installing. Oh, you've done it in the Docker. Cool.
Okay. So I'm using the here docs. Like that I can show off that even IntelliJ is not able to understand how it works.
So you've cheated a little bit by not putting it in the Py project.
It's not cheating. I'm doing, again, I don't want to bother the developers. I do it at runtime, which here is build time. So I install Poetry, obviously. Then I add the Poetry dependencies that I've created. And then I add actually the OpenTelemetry distro OpenTelemetry. And very important, I have a new command that appears called OpenTelemetry Bootstrap that allows me, well, it allows the stuff to sniff every dependency my project has to check if there is an OpenTelemetry library that is focused on this dependency.
And that's why you have Flask 2 and not 3.
And what I have?
That's why you have Flask 2 and not 3, because it doesn't work for Flask 3.
That I don't know. But that's the reason why on the Python code as well, I have nothing that is OpenTelemetry related, and still I've got the nice stuff. So as I mentioned, once you start with this, you can ask for more budget because it's so cool that you've got nice results. So I will add this stuff, and I will be a bit faster. And I go to the next step, which is manual instrumentation. Docker compose app. So now I've added in my Py project the OpenTelemetry distro. On the Java side, I have added the OpenTelemetry annotations project. And now on my app, I have added with span. I don't know why it doesn't compile now, but believe me, it works. Well, no, you shouldn't believe me. You should do it yourself. And it means that previously, you saw that actually I like tracked when I received the requests, and I tracked when I send the request. Right? Now, if I do it again, and it's done, I should curl. And I should get back here. I should refresh. And I find the trace. Now I had 29. Now I have a bit more. And actually now I have this find all stuff that I, where is it? Yeah, find all. There. Nope, not here. So find all, sorry, is the name of the repository. And I have the fetch here. So the fetch is the with this one. So basically, if I have with span, the name of the span will be just the name of the method, but I can override it with the name of the class as well and do whatever I want. What I can also do is add additional attributes. Just like I did with the header in API 6, I can have this span attribute. And here it's a bit misleading because actually it's the ID of the product, but I'm also passing the product along. So I need to artificially change the signature of the method because I'm just using annotations. So here it will tell me, hey, you are not using ID. Indeed, I'm not using ID, I'm just using it here. But it still works. And now, when I am doing the fetch, I should have the product ID here, 1. And on the Python side, I did the same. So when I check here, I should have also product ID 1. If there is a bug, you can check that I'm getting the product ID 1 for the price, I'm getting the price for product ID 1 from the catalog of product ID 1. So it matches, everything is fine. I have 4 minutes. I will continue to the next step, which is the asynchronous stuff. And the asynchronous stuff is, okay, Nicolas, everything works magically, but because I told you, it works with the HTTP header. Basically, that's what the library do, is they get the HTTP header, then they create the new span ID, and then they continue the stuff when they are calling, they are putting the header as well. So how does it work with Kafka? How does it work with messaging? You don't have HTTP header. That's true. So I need to do everything by myself. And it's still fine. So what I've added here is I've added an additional library. And this one, is OpenTelemetry API. So now it's not only about just like annotations, I'm using the API directly. And I've added a filter. I don't know why it doesn't compile. I should probably do something like this. Rebuild module catalog. Yeah. Oh, it's so slow. Okay, anyway. I've added a filter, that's the analytics filter. And basically, everything that the library did under the hood, I'm doing it by myself. So I'm getting the header, that is easy, the HTTP header. And then when I'm creating the message, basically it depends on your infrastructure. If you have on some infrastructure, you don't have metadata, so you need to put this data inside your message. Here I'm using MQTT-v5 underneath, so there is a metadata space where I can put this trace ID and the span ID. And that's what I'm doing. It doesn't work. Malaka, sorry. I shouldn't say it. You can remove it when you do post-processing, sorry. And that's how it works. So now I have even more spans. You see that I have an additional component, that's my Node.js component. And here, it finishes the span. And we can be sure that it works by doing the following. I will Docker compose stop the analytics, Docker compose stop analytics. Okay, it is stopping the analytics. Do it, please. Okay, I do the same. I get back, I find the trace. It was too fast. So, and we see that now the analytics, of course, doesn't work, right? There is no analytics. We cannot fit here. But if we start it again, then it will subscribe to the queue, get the message, and send the data to OpenTelemetry collector, to Jaeger. Did I do it? Yes. It's this. Oh, of course, it's the same. So now we have 34 spans. And you see that, of course, that it's pushed on both sides because I waited a lot and it's in milliseconds, and what is in between is in seconds. But still, it's still the same trace. And that's how it works, ladies and gentlemen. And I just finished at 45, which is exactly what I should have done, right? Where is the volunteer? He's gone. Here. You are too fast. You just move. I didn't check. And thanks for your attention. You can follow me on Twitter, even though it's dead. You can follow me on Mastodon. You can follow me on Blue Sky, because I have no clue what the next thing will be. I promised you the code, so it's on GitHub. Underneath the bit.ly, there is a GitHub link, but I want to check how many people are actually looking at my source code, how many people are trusting me and not. And if I got you interested in Apache API 6, though the talk was not about Apache API 6, you're welcome to have a look. It allows me to travel to Greece and to give nice talks. So please have a look. Thanks a lot. So now I'm competing with lunch for questions. So I don't want to compete. I don't want you to stay there. There are stickers in front if you are not too hungry. You can come to me and ask questions. Unfortunately, tomorrow I will be leaving, so you need to find me today. Thanks. Ευχαριστώ πολύ.